Welcome. Let's talk about the energy systems, which are now on the market with three main applications: sanitary hot water, central heating, and climatization of pools. We'll start by explaining the ecothermal equipment, which is the reference used in the energy systems for sanitary hot water. The ecothermal is made up of several components. During this first phase, only the three main ones will be pointed out: thermodynamic block, water heater, and solar panel. The solar panel is made of aluminium sheet, which goes through different stages and high-technology processes. It's previously coated with an anodized layer and with a selective surface finishing. Its size, robustness, and treatment afforded the ability to withstand the impact generated by bad weather as well as environmental stressors, rain, UV rays, hail, etc. Weighing only 8 kilos, this panel has countless installation advantages, combined with its dimensions of only 2 meters long by 80 centimeters high. The thermodynamic block is the component which transforms the energy coming from solar panels into heat, which will in turn heat the water which is inside the water heater. The block comprises several units, highlighting the compressor, the exchanger, the liquid tank, and the expansion valve. All the units are fixed to a stainless steel base, which is coupled to the water heater, leaving the condenser dipped into inside. The water heater is the component of the energy system where the hot water is stored. It's made of stainless steel, insulated with polyurethane and coated with high-impact polystyrene, thereby ensuring all the mechanical resistance and insulting quality required by a high-quality product. So let's take a look at the preparations for installing an ecothermal. The first step for the installation of the ecothermal is to analyze the best location for placing the panel and the water heater, with the priorities being the best orientation and tilt of the panel, the minimum distance between the panel and the water heater, and also at the site where the water heater is to be installed, there should be electrical power, a cold water source, a hot water source, a turning point, and sewage. 4 factors will be required in order to install the panel: orientation, inclination, architectonic integration, securing. With regard to orientation, the panels should preferably be oriented southwards, but they also have an orientation towards the northeast or northwest. However, the panels should not be pointed northwards. The inclination angle of the solar rays in relation to the ground varies according to the seasons of the year. To make the most of the energy emitted by the sun, you should choose an inclination between 45 and 90 degrees. However, the panels can be installed with less inclination, but they should never be completely horizontal. The technical component of the installation should always be balanced with the aesthetic component, which is why the panels should be installed on rooftops, verandas, walls, the ground, or other locations that are best suited to sun exposure. All the components of the ecothermal models are carefully packed in individual boxes. Solar panels are typically secured with a L-profile aluminium structure, which affixes the panel to the surface in 6 points of the latter. To secure the tile, follow the steps below. Mark the point where the tile will be drilled. Drill the tile. Place a brushing. Place a bit of silicone. Set the profile and screw it tight. Seal the base and the foundation with silicone. The solar panels are secured to the brackets using 6M6 screws, which are supplied with the equipment. The fixing structure of the panels should have mechanical robustness, capable of withstanding the impacts caused by bad weather such as rain, hail, wind, etc. It should also be stressed that there are two types of panels, the right panels and the left panels. The solar panels should always be placed at the bottom. In other words, the greater length should be on the horizontal position with the connections facing downwards. Before inserting the exchanger inside the heater, you should guarantee that the edgings are not in contact with the exchanger, checking whether or not there is a continuity between the two surfaces. It should also be checked that the thermodynamic block is nitrogen loaded. It is also necessary to apply grease, in this case the well-known Vedox, in the seal joint in order to ensure it's fully extended inside the flange, thus avoiding water leakage problems. With two screws, attach the thermodynamic block to the flange of the water heater and then tighten crosswise the 12 screws provided with the equipment. The power supply should be provided by the power cable supplied. The electric supply line should be protected by a magnetothermal cutout of 10 amps in the case of the Echo 200 and 300, and a cutout of 16 amps in the case of the Echo 200 and 300 ES and 500, or by an equivalent fuse. The water heater can be placed in different compartments such as the garage, the basement, the pantry, the attic, etc. To respond to the greatest number of possible situations, there are different types of water heaters. The references used most are Echo 200, Echo 300 and Echo 500. All energy water heaters have a hot water outlet, return, magnesium anode and a cold water inlet. Apply the magnesium anode in the respective hole, tightening accordingly. The equipment comes with a pressure-reducing valve and a safety unit which should always be installed for protection of the whole installation. We can now proceed to fill the water heater, open the water inlet valve and tap in order to remove the air inside the water heater. The connection between the solar panels and the thermodynamic block is achieved by a way of dehydrated copper pipe. The advantages of copper over the types of material are numerous, namely high resistance to corrosion, high thermal conductivity, great elasticity. It's profitable, efficient, aesthetic, 100% recyclable. Once all the components which are part of the energy system have been presented, we will describe all the steps for correct installation, starting with the connection of the panel to the thermodynamic block. Firstly, unwind the copper pipe from where the block is placed to where the panel is located. With the aid of the pipe cutting tool, cut the pipe in the desired measurement. Do not forget to remove the cut edges. The ends of the pipe should be covered so as to ensure that it is protected from humidity and dirt. For the copper pipe to be aligned with the pipes of the panel, bend the piping using the pipe bending tool. This can also be done by hand. With the aid of the pipe cutting tool, remove the safety cover and put it back whilst proceeding with the other operations. Then, heat the ends of the pipe up a bit, which we will expand so that it does not suffer any rupture. Expand the pipe a little so as to fit in the solar panel connection. Before starting the welding, it is crucial to protect the shrinkable joint with a damp cloth. The kind of welding recommended to connect the pipes is the oxyacetylene welding. However, another type of gas may be used, for example propane, with a silver rod at 40%. This should always be done taking great care not to damage the panel with the high temperatures caused by the flame torch. After the welding is finished, you should use a damp cloth to cool it down. The connection of the pipe to the block should be initiated by a correct measurement of the pipe length. First, using the pipe cutting tool, you should cut the pipes at the exact point of connection. Use the reamer to remove the existing edges. Repeat the heating and expanding of the pipes as mentioned before. To guarantee there are no impurities inside the pipes, nitrogen scavenging should be carried out by passing nitrogen through one of the ends of the pipe while pressing with your finger on the other end. Repeat this operation 2 or 3 times to guarantee the cleanliness of the entire circuit. After carrying out the scavenge, you should cut the pipes of the block at the correct measurement for the welding. Never forget to always ream whenever cuts are made. Before performing the welding, a correct measurement of the pipes should be carried out so that the bending is appropriate for the block's height. Once again, take special care with the flame torch in order not to damage any of the components. Once all the welding have been carried out, the equipment should be subject to a shut-off test. In other words, to guarantee that there are no circuit leakages. Then carry out the nitrogen load through the suction nozzle at a pressure of 12 bars. When it reaches the pressure of 12 bars inside the circuit, the valve on the nitrogen bottle closes. Wrap all the welds in soap foam. Soap foam allows you to see if there are any leaks. Read the nitrogen bottle manometer and check the pointer hasn't moved. You can then be sure that there are no circuit leakages. We can only proceed with the installation of the equipment when it has been ensured that there are no leakages. For system and installation vacuuming operations, the system as well as the loading thereof, there are different market solutions. Traditional loading station, automatic loading station, individual equipment. In this installation, we opt to use individual equipment. The vacuum aims to remove all the existing air and humidity in the circuit. To vacuum the installation, we should start by connecting their hoses, high and low, to the corresponding valves. By connecting the hoses to the block, the nozzles of the ends are used to remove the nitrogen from inside the circuit. Nitrogen gas is a completely inoffensive gas and does not cause any harm to the environment. All hoses should be tightened with all 4 strainers being closed. Open the vacuum hoses valve and high and low valve, turn on the pump and observe how the pressure of all the manometers decreases. The minimum time of vacuum recommended is 1.5 hours. Self-evidently, the longer the vacuum the installation, the drier, the less humid the circuit will be. After the 1.5 hours of vacuum, shut down the pump and close the low and high strainers and vacuum. Verify the manometer's pressure. If the pressure increases, it means that the circuit is not airtight. In other words, there are leakages. The fluid used is the R134A. It is a pure synthetic fluid which is totally ecological. With this fluid, the loading can be carried out both at a liquid and a gaseous stage. However, it is more usual to execute a liquid loading. Furthermore, it is totally safe and also quicker. Initially, what we have to do is to verify the kind of bottle. It is to know whether the bottle has an interior pipe or not. To verify it, open the valve and see if the fluid comes out in a liquid or gaseous stage. If you turn over the bottle and open the valve, you see that it comes out at a liquid stage, meaning we have to carry out the loading with the bottle upside down. Connect the bottle to the fluid jar and to the corresponding valve. Open the valve and purge the hose to prevent air from remaining inside. With the help of a scale, check the exact weight and the quantity of fluid which has to be inserted in the system. At that moment, open the high valve and the fluid starts to enter the circuit. After the desired loading has been carried out, the solar system should be at rest for some minutes so the pressure is equalized. Before starting the system, it is necessary to guarantee that the water heater is completely full of water. Then you should connect the block and the command, which is located at the hood. The hood is secured to the block by 2 screws. Besides having the control panel, it has the function of protecting the thermodynamic block components. After completing all these steps, the energy thermodynamic solar system is ready to be used.